Okay, the recording has been started. So yesterday, still we are discussing about the hotel management application. I think now you have got a complete understanding about the intermediate operation methods and the terminal operation methods. You got some picture about how to utilize this stream methods effectively. Right? If you ever asked to do some kind of data computations, let us the example that we have been discussing so far, the dish example. There will be a variety of dishes, and each and every dish is going to have a kind of properties like the name of the dish property, a calories property, and it will also ensure whether the food is vegetarian or non-vegetarian, and the type of the food and the price money. So if you want, you can add any number of properties. You can practice the methods that we have been discussing so far, the filter method and everything. So yesterday, we have completed almost all the methods. Each and every method has been completed clearly, right? Today I want you to understand about there is a concept in Java 8, especially when it comes to stream APIs. You may get this question in the interview room. Okay, so the question could be like the difference between the stateless versus the stateful operations. Very important question in the interview point of view, right? Stateless and the stateful operations. So when you pick up each and every methods in the stream APIs, for example, so these are the methods in the stream APIs, right? So these are the few methods in the stream APIs. So I could say that the filter method is a stateless method. Filter method is what? The stateless method. The map method is the stateless method, I could say, right? I could say that the limit method is stateful method. Stateful. And I could say that the sorted method is also what? Sorted method is the stateful method, right? And I could also say that the distinct method. The distinct method is also what? The distinct method is stateful method. Okay, how I am able to differentiate the methods like stateless method and stateful method. So that we are going to understand today. Why we are calling the filter method as stateless, and why we have to call the limit method as stateful. So what is the idea behind calling these methods as stateless as well as stateful operations? I can say we are going to understand that concept today. Before even understanding this, I want to introduce some set of, if you want to produce the streams directly, for example, I want to produce the stream of numbers directly without getting the data source. Let me repeat. So far we are converting the data source, right? So you have a collection object and you pick up a collection object. It could be array list, it could be linked list, it could be asset, anything. You will pick up a collection object. The collection object is getting converted to stream by using what? By using a method called the stream method. Sir, no? Right? By using a method called stream method, the data source is getting converted to stream. Right? So, but I have a requirement like I do not want to use a data source to generate the stream. Right? If in such cases, what I could do, I can directly go for what? I can directly generate my own stream by using some static stream methods in the stream APIs, right? Without using the data store. I do not want to use the data source, but I want to generate some stream, guys. I don't want to go with the data source, but I want to generate some streams. What is an alternative? Okay, so there are some methods that you can generate stream. The methods are like, so there is a method inside the stream class called off method is there. So in the off method, you can directly pass some values like 1, 2, 3, 4, 5. Some values you can pass. So this is a stream. This is a direct stream, I can say. Right? If I want to produce the infinite stream, there is a method called stream.iterate method is there. Okay. This iterate method is going to accept a seed value. I will tell you what is that seed value. It is going to accept a seed value. Seed value is just like a kind of a seed. From the seed value, you will be able to generate what? The infinite numbers. For example, let us say that the seed value is 1, right? And you can use a binary operator to generate the infinite stream like this. I mean, the iterate method is going to accept two arguments. The first argument is a seed argument, which is going to be any numerical value from this seed. From this, it is just like an initialization. From this initialized value, you can keep producing the numbers. Okay, and there is another method called the generate method is there. Okay, this generate method will help you to produce the infinite stream, but it is going to accept an argument called the supplier as an argument, supplier interface as an argument. Okay, and the last method, and not the last method, these are the famous method that you have to understand the stateful and the stateless operations. There is a method called empty method, right? So when the stream is empty, in some cases, okay, the empty stream needs to be written. In such cases, you can use this method. We will understand this in the real-time examples. Okay, so for now, you understand that there are four main methods inside the stream APIs. One is the off method, second one is the iterate method, third one is what, the generate method, and the fourth method is what, empty method. What we are going to do with these methods, we are just going to understand the definition of the stateless as well as the stateful operations, right? Stay focused, this is going to be very interesting. Firstly, let us pick up this method. The method that I am talking about is what? The first method, stream.off method. Okay, so let's try to understand the difference. We want to take 5 numbers from the data source. What is the option for me? Usually we have been doing what? I am going to consider the collection class, which is the list of integer in numbers equal to arrays.asList. Okay, so this is how I consider the first 5 numbers, right? And if you want to perform the computations by using the stream APIs, we already know that how the computation happens. First, you need to take the data source, which is numbers, then you convert it to stream, isn't it? Okay, and if you want to perform any kind of computation, to keep it simple, I want to filter only the even numbers. What I'm using here, I percentage of 2 double equal to 0, so that even numbers is going to get filtered. And the for each method, it is a terminal operation which is going to help us to printing the values in the console. Okay, this is what we have been doing. So we depended upon the stream, we depended upon the data source actually, but I do not want to depend upon the data source. How I can achieve this? Okay, I can directly generate the stream just like this. Okay, there is a method called stream.off method. So you can pass the numbers which you want to manipulate, okay, as an argument. I am passing the 5 numbers. So the return type is what? The return type is the stream itself. Stream of integer values numbers, right? So you are directly producing a stream here. There is a minor difference between this line of code and this line of code. What is the difference? You are depending upon the data source and you're converting that data source to a stream actually. But in this case, you're not depending upon the data source. Okay, you're directly generating the stream by yourself. It is just like a factory. This factory's off method is just like a factory. It is going to generate the stream of values, stream of elements which you like. In this case, I want to generate the stream of values, and the values are supposed to be 1 2 3 4 5. I can do this. So now I can do what? So these numbers are stream itself. Then I can perform the actual operation which I want to perform. You do not want to convert this to stream once again. You can directly perform the mathematical operation. Okay, let me put this here. Let me put this in the main screen. Okay. Now you see, guys, focus here. Okay, so this is the data source. Okay, you are depending upon the data source, and from the data source, you are converting the data source to what? To the stream. Right? This is the typical example, actual example. This is the example which we have been discussing for the last 7 days, right? But if I do not want to depend upon any data source, if I want to generate my own stream, what I'm saying is I can do like this. Okay, I can this is how my own stream can be generated. Okay, now this numbers is not a data source. This numbers is just a stream. It's a stream actually, because stream has been generated by you without depending upon any data source. You're able to follow, right? So now, okay, this is fine. Okay, we're able to understand. Okay, what is the purpose of discussing all this? Let me remove this. Okay, this is nonsense now. Do not want to discuss about this. Okay, let me keep it here. Okay, so stream of numbers I have. Okay, now you observe one thing, guys. You focus one thing. A very, very important observation. This one is. I'm just clicking on the filter method. You know, filter method is an intermediate operation, right? And just look at this, guys. It's saying filter method is a stateless predicate. It is accepting a stateless predicate. Why you call it as a stateless? For what reason? What does it mean to be a stateless? First of all, stateless. Okay, remember this. I think you have watched the Gajini movie in Tamil version, in Telugu version, in Hindi version, right? Actor Surya, I know, one of the fantastic acting done by him. He forgets everything, isn't it? Okay, he don't remember whatever the things are happening around him. I mean, the memory period is could be for 30 seconds. After that, he forgets what he sees and what he witnesses, whatever it is. The filter method is just like the Gajini of stream APIs. To be honest, okay. Let me copy the code here. Okay. So what they are saying, filter method is a stateless. They are saying filter method is what? The stateless operation. Stateless means memoryless, I can say. Stateless means what? It will not what we call it as it is not going to remember each and every element that is accepted by the filter method. You're able to follow. What is the stateless? It is not going to keep everything in the memory. It is not going to keep everything in the memory that is accepted by the filter method. Filter method, what does it actually do? It takes each element from the input stream. Okay, usually from the stream it will take each and every element from the stream. The purpose of filter method is it will consume each and every element from the stream, right? And after the consumption, okay, it is going to produce the output as the stream itself. But the problem here is generally it is stateless because it don't have any kind of internal state. No internal state is there. Okay, let me put this in a different way. How many elements we are passing? We have 5, 4, 3, 2, 1. So this is the stream of elements. Okay, and each and every element is going to go inside the filter method. The filter method is going to have a predicate as an argument. The purpose of predicate method is to do the computations. That's it. It will not store the value. Okay, if the predicate is matching, it is happy. If it is not matching, this is going to get destroyed. 1 is not an even number. It will be destroyed, isn't it? Right? 1 is not an even number. This is going to get destroyed. Okay, next number. What is the next number? 2. By the time the 2 comes, it is not going to remember it was actually dealing with 1. There is, I mean, it is not going to store the value 1. Okay, 1 is then and there destroyed. That's it. And 2 comes. Okay, it is going to do the computations and mathematical calculations whether to check whether the 2 is the even number or the odd number. Okay, it knows very well that 2 is the even number. It gives this to the for each loop. The purpose of the for each loop to consume and print it in the console. Okay, then it has forgotten about the number 2. No storage. It's not storing anywhere. The element is not getting stored anywhere by the filter method. Okay, it is just taking, it is just processing and forgetting. What is happening? Just taking, just processing and forgetting. Internally, no mutation is happening here. Try to understand. It is not doing any kind of manipulation actually. It's saying whether true or false. That's it. Apart from that, it doesn't know anything. Okay, whatever you give, I will filter method is like just like this. Okay, hey, I am in the filter method. Whatever you give it to me, I'm going to check whether it is it is matching the predicate or not matching the predicate. That's my job. My job is not to give some storage to it. Then and there, if the element is when the predicate is not matching, it is getting destroyed. If it is matching, okay, it is getting a pipeline to the for each method, right? And this process is called as what? This operation is called as what? Stateless. Are you able to get it? What is stateless is, right? So now you see. Okay, let me go back to the code. Okay. Filter method. Okay, I am just hovering over it. It says filter method is the stateless predicate to apply, right? Now what I want to do, now I want to deal with the map method. Okay, forget about the filter method. I want to deal with the map method. Map method is going to accept a function. Map method is going to do the transformation, right? Transformation. Okay. So my requirement is I want to accept each and every input from the streams, each and every element from the streams. I want to double the number, double it, right? Now if I just over it, see, look at the map method. Map method is also stateless. Why? What is the job of the map method, guys? What is the actual job of the map method? Run this piece of code. You get 2, 4, 6, 8, 10. Why you are getting 2, 4, 6, 8, 10? Let me use the paint screen. Okay, so this is the lambda expression. I mean the stream API operation. A kind of query I can say. Okay, you have the pipeline. You have the pipeline of numbers 1, 2, 3, 4, 5. Right? Okay, numbers are pipeline like this. So one will be accepted by the map. Map is going to deal with the function. Argument is function itself. The map is going to just it will perform the transformation. It is like another Gajini. Okay, so you give me the input and I am going to transform that input to a different output, and I will forget whatever it is. That's it. Another Gajini. Okay, these things will never get stored in the memory by the map. Map will not do a kind of mutations behind the scenes. Okay, you accept and I transform. I mean map is like I accept and I transform it to another expression or another element depending upon the lambda expression, and I give it to the for each method, right? It is not what we call it as it is not keeping everything in the memory, right? Only one element will pass. Try to understand. Okay, once, so next element is 3, right? As soon as the transformation for the 3 is completed, how the 3 is going to get transformed according to the lambda expression, 3 becomes 6. Okay, once this 6 is accepted by the terminal operation, okay, then again the terminal operation will check with the streams, is there any other element? Okay, then it says yes, I have another element called 4 element. It will be accepted by map. Okay, and it is going to do the transformation. 4 plus 4 is going to be 8, right? And 8 will be given, right? And 5. Last again it will check is there any other element. 5 is already there, right? And 5 becomes what? 5 is going to get transformed to 10, isn't it? Okay, 10 will be given to for each method. For each method will check is there any other element. No, there are no such element. Okay, terminated. Right. In this case, this map is also just like Gajini. It is not remembering anything. Stateless operation. Okay, it is just like these operations are they generally call as stateless because they are not dealing with any internal state. Internal state is not there. Okay, so now I can say map is stateless and filter is also stateless, right? And we have discussed so many methods in between, right? We have discussed how many methods, like there is a method called, okay, now look at this, now focus this. You have, so let us understand something about stateful operation, right? So let me what is the purpose of off method? You are going to generate your own stream without depending upon the data source. Okay, now I want to introduce the another stream called intg. This stream is what of integer type, right? And I want to generate infinite stream. Okay? Infinite stream. Now focus here. To generate an infinite stream, there is a method called iterate method. Okay? Iterate method is going to accept 2 arguments. So, okay. One is what? One is the seed, you call it. The second one is a functional interface. I mean, I just mentioned that it was a binary operator. It was not a binary operator. It's a unary operator. Okay, let me put this here. Okay, let us use this space, guys. Okay, so when you are giving an interview, so you get these questions like what is stateless, what is stateful, You should not get any panic. If you just answer that memory, if you just remember about the memory, I think you are good to answer these questions. They don't ask much. Okay, you can, for the pressure level, even for the experience level, they just want to understand whether you know the, uh, what we call it as, whether you are acquainted with these words like stateful and stateless. Now you see this line, infinite, you want to generate the infinite stream. I am using the iterate method. Okay, this iterate method is going to accept two arguments. Okay, the first argument is going to be a seed. Seed is like seeding something. You can pass any number here. For example, if you pass a number like 1 is like a seed, right? And the second argument is going to be a unary operator. Unary operator is just like it will accept one input, and you can give the own lambda expression. Okay, it depends upon your requirement actually, right? You want to generate an infinite stream. How does the infinite stream is supposed to look like? Okay, you accept the number and you want to manipulate that number like I plus I, something like this. What does it really mean? So this is called as seed. The first argument is called as what? Seed. What does it says? First argument is called as what? Seed. Remember, seed. Okay, and this seed value is 1, right? So this 1 will go as an input to the unary operator, and the manipulation will happen like 1 becomes what? What is a lambda expression? 1 plus, I mean I plus I, right? 1 plus 1 becomes 2, right? And again next time the generated output, okay, 2 is going to be the new produced value, and 2 becomes the seed again. 2 is going to be the seed again. Okay, seed again. 2 is the seed. Okay, and again 2 will be accepted by this lambda expression. 2 becomes the input. 2 plus 2 is going to be what? 4. Or no? And 4 becomes the new seed again. Okay, like this, it is going to do this infinite number of times. Okay, you cannot stop this. Can you stop this? No, you cannot stop this. Why you cannot stop this? Because iterate method is going to generate as long as you do something to stop it. As long as you do something to stop it, is going to generate. So what is the seed value I want to pass? If I ever had to pass 1, and right, and the lambda expression is what? I. This is the unary operator. You know what is a unary operator? If you don't know, just go back to my video and see what is the unary operator. It is going to accept one input and it is going to produce the input type, and the output type is going to be same. Integer, it is accepting an integer. Let's produce the return type is also integer. Okay, what I want to do, use this stream. Okay, and if you by using the for each loop, I just want to print, okay, what are the values that it is printing, right? Okay, so I'm taking the stream and I'm using the for each method to check what are the values that is going to print. It is okay. 1 minute. I think there is something wrong with the seed value. 1 minute. Okay, it keeps printing. Okay, wait. I want to stop this. So it keeps printing infinitely. Okay, so you should find a way to stop it. It is going to keep printing the values what? Infinite number of times. See, I'm not able to find the first thing. So why we are discussing about this infinite stream? Why we are discussing actually? Because now we should understand something about the intermediate operation along with the short circuiting operation we need to understand. Okay, we need to understand what the short circuiting operation. What is a short circuiting operation actually? So you are producing the infinite stream here. You are doing what? You are actually doing what? You are actually producing the infinite stream here, right? So once you are producing the infinite stream, you want to find a way to stop this. But if you remember in the Java API, the Java Stream APIs, right? You have discussed about a method called the limit method, and you have also discussed about something like the skip method. Yes or no? So you have discussed about the limit method and you have discussed about the what? Skip method. right? Now you see, so I am operating an infinite stream dot limit. Okay, there is a method called limit. So this limit method is going to accept a value called the long value, right? It is going to accept a value called what? A value called the long value, right? For example, if you are passing something like 5, what it is actually doing, let me hover over the mouse here. It says short circuiting stateful intermediate operation. Okay, limit method in Java Stream APIs, limit method. So when you're dealing with limit method, so limit method is going to be like, okay, you can call it as the stateful operation, okay, and you can also call it as the short circuiting operation. What does it really mean? Short circuiting operation, right? So, and this limit method is going to accept an argument of what type? It is going to accept an argument of long type, long data type. So you are forced to pass some value inside the limit method. Okay, now I want to pass something like I want to pass 5. If I pass 5 and if I run this piece of code, right, only 5 numbers are getting printed. 1, 2, 3, 4, 5. Actually, I did a mistake in the explanation. Okay, the seed method is going to be the initial value, right? And this initial value gets printed over and over again. So this initial value will be accepted in the lambda expression and it gets printed over and over again, right? If I run this piece of code along with the initial value, first initial value will be printed, then the lambda expression operation will be applied. 2, 3, 4, 5. Okay. Seed value will be printed first, followed by the lambda expression. For example, if you take 2, okay, now 2 will be printed, then the lambda expression is going to get applied. Right? For example, if I take this the seed value as 10, first 10 will be printed, then 10 will be consumed by the lambda expression, then this is going to print the values from 10 to according to the lambda expression that you are specifying here, right? 11 to 11. So let us keep this simple example 1. Okay, now see, limit method is a short circuiting method as well as it is stateful method. What is happening behind the scenes? So you have the infinite stream base, okay, and your numbers are what? Infinite stream. Focus here. Okay, now focus here. Yes, you have an infinite stream. The purpose of infinite stream is what? It is just like a factory. It is going to produce infinite numbers starting from 1, right? 1 will be the seed value, it will be displayed first, and the lambda expression will be applied repeatedly, infinitely, I can say, right? And if without using the limit method, and you cannot expect the program to get terminated. As long as you have the sufficient memory, it keeps printing the values, infinite number of values, right? But you need to stop it some way. So you are using what? You are using the limit method. So what is the limit method? Limit method, there is a stateful operation and short circuiting operation. What does a stateful mean? See, the infinite stream is going to produce values from 1, okay, 1, 2, 3, 4, 5, and it keeps producing, right? So this is a stream of values. Limit method will accept. Okay, limit method, what does it actually do? Limit method will keep this in the memory. Behind the scenes, it is going to keep everything in the memory as long as the condition is satisfied. What is the condition? It needs to accept to 5 number of elements. So limit method will keep all the elements one by one that is coming across. 1, 2, 3, 4, 5. Right? Now the count is matching. Okay, because you have passed the 5 as an argument, so it is going to keep all the 5 elements. 1, 2, 3, 4, 5. Right? We're going to keep all the 5 elements those 5 elements, then it has found that okay, condition is matching. Okay, then it will perform the short circuiting. Before perform the short circuiting, all these 5 elements will be there within the memory of the limit. Okay, limit method keeps everything in the memory because you are passing an argument. Okay, that argument needs to be matched by the limit method. So it has to deal with the kind of memory, because memory is going to tell the limit method that the operation is successful according to the argument that you have passed. Five elements it needs to remember. Okay, then these 5 elements will be accepted by the for each method, right? 2, 3, 4, 5. Okay, so this operation is stateful operation. Okay, this processing is called as what? Stateful operation. Okay, then it performs the short circuiting because you are dealing with infinite stream. It needs to terminate this condition, terminates the query. Okay, because the condition is satisfied, it does what? As soon as the condition is met, it will perform the short circuiting. Right? No, it's not required to print all the values because the requirement is actually 5. Limit is taking care of that requirement. As soon as the requirement is fulfilled, it is not necessary to deal with the remaining numbers. So the short circuiting will happen. The logic will get terminated. So infinite stream will become finite stream now. Hope you're able to understand what is a short circuiting operation. See guys, you know what is an AND operator. You know what is an AND operator. In Java, you know very well that what is an AND operator. Right? So AND operator, okay, you pass the logical entities like, for example, true. Okay. You want to check this true, and again then you want to check what? True, and again then you want to check what? True, and again then you want to check what? The condition false, and again then you want to check what? True, and again then you want to check what? True. Okay. See, short circuiting is just like this. See, you have the sequence of AND operators that is dealing with the logical entities like true and false. Right? So what actually short circuiting operator does? Will check for first 2 conditions. Okay, true is always true. Okay, and again the resultant value will be checked upon the next condition. True is always going to be true. Again the resultant value will be checked on the next condition. True is always going to be true. Again the resultant value will be checked on the next condition. True, false. As soon as the false is encountered, no matter what, okay, everything is going to be false itself. As soon as it sees one false, you may have any number of the conditions. You may have infinite number of conditions here. Infinite number of conditions here, right? Infinite number of conditions here. No matter once there is a false, everything is going to be false. Okay, the computer stops checking the remaining elements. It is going to short circuit it. It will evaluate the result directly. It has found one false. Of course, once false is found, then the AND operator will ensure that everything is going to be false, no matter how many truths are there. Are able to follow? Right? Just like that. Limit is just like that. Limit method is going to ensure that as soon as the condition is met, what is the purpose of learning this to infinite number of times? That's why they call it as limit method. Is a kind of short circuiting stateful intermediate operation. Short circuiting means once the condition is met, even if the loop is if the stream is an infinite, no matter, it is going to short circuit. Right? Why it is stateful? Because it has to keep the things in the memory. Just to do what? It has to keep the things in the memory. Now we have understood what is stateful. You have understood what is stateless. You have understood what is the what we call as the short circuiting methods. Now you must understand. You must also understand one more thing. Okay. Now let us remove this. Okay. I want to deal with a simple stream of integer. Right. Stream of integer. So you want to sort element. Okay. Let me take some numbers. So your stream as stream dot of some stream of numbers. Right? For example, 100, 200, 12, 13, 45, what is it, 26, something like 1, 2, 3. Right? Perfect. You have some numbers, and you are taking the stream now. Okay, numbers is itself the stream. Now you want to sort this. You want to use the sorted method. After sorting the elements, you want to display it in the console directly. Right? You want to display this in the console in the sorted format, right? Run this code. All the elements are sorted in the ascending order, natural sorting order. If you just hover over your mouse on the sorted method, it says stateful. Again, sorted method is what? Stateful. Let me tell you something. Sorted method is stateful, but sorted method is also what? The unbounded stateful operation. Unbounded. I will tell you what is it. So this is the code. This is the code. It is looking good now. See, you have passed some numbers to the sorted method. These are the numbers, right? So right. Okay, these are the numbers inside the sorted method. Not inside the sorted method. Actually, these are the numbers. Stream of numbers. Okay, so the stream of numbers will be accepted one by one by the sorted method. First 100 will be accepted, then 200 will be accepted, right? So it has to internally do the sorting. As soon as it is accepting, it has to do the sorting internally. Then 12 will be accepted. So 12, according to natural sorting order, 12 is going to occupy the first position among these three numbers. Then 23 will be accepted. Okay, 23 should come around here. It is going to accept each and every number from the stream, right? And 45 will be accepted, will be here, and 26 will be accepted, and the placeholder for the 26 is, because it is sorting. Okay, the moment the elements are accepted, is going to sort. Okay, then 1 will be accepted, 1 will be here. Okay, and 2 will be accepted, 2 will be here, right? After that, 3 is going to get accepted, and 3 will be here, right? So it has to remember each and every element. Memory is required. It has to remember each and every element. That's why this operation is called as what? Stateful. Only when the numbers are remembered, only when the numbers are stored, it could able to do the actual sorting behind the scenes, isn't it? Yes or no? Okay, that's why sorted method is called as what? The stateful operation, because it has to deal with the memory. Internally, it has to remember the state of the elements. Okay, I have also mentioned a word called unbounded. And unbounded. What does the unbounded mean? You first understand stateful. You understood what is stateful. After doing the sorting, then according to the sorting order, each and every element will be passed to the pipeline, and this is going to get displayed in the console by the for each loop. 1 becomes here, 2, 3, likewise. And in this order, it is going to get displayed in the console. Okay, I just mentioned that it is an unbounded stateful operation. Unbounded means if you are dealing with the infinite stream. Okay, this is the finite stream, finite number of values. If you ever had to deal with the infinite stream, iterate. Okay, seed value is 1. Okay, and you want to do what? You want to use the unary operator. First 1 will be printed, then this unary operator will take 1, right? And you are adding 1 on top of 1. Okay, this is going to produce the infinite state. Now observe one thing. There's a problem here. If you run this code, you don't get anything in the console. Why you don't get anything in the console? Is it not doing? See, out of memory you are getting. Why out of memory in the if space? Very dangerous exception, this one. What is happening behind the scenes, guys? Java is very clever. See, why I mentioned unbounded? Why did I just mention unbounded? That understanding is required. Okay, now don't you think so? Don't you think that this numbers is a variable of stream which is going to generate infinite numbers? Infinite numbers are getting generated, right? The numbers are infinite because you are using the iterate method. The purpose of iterate method is going to generate what? Infinite numbers, right? Your stream is generating infinite numbers, right? Don't you think that this sorted method needs to wait for all the numbers, infinite numbers, to get sorted? Yes or no? Just to wait as long as the lifespan of the the lifespan of the memory gets over. It has to wait for the infinite numbers. Yes or no? Because it is stateful. It has to wait as long as it consumes all the numbers, right? Then it can work on the sorting operation, so that after working on the sorting operations, the for each element, for each method will come into the picture, so that it is going to accept each and every value and display in the console. But the problem here is these numbers is the what? Numbers is a variable which is producing infinite streams. It can it wait for infinite numbers? Is there any point where the infinity is going to get broken? Is there any points? Right? So that's why it is called as what? The stateless and unbounded. Unbounded. It is not bounded by a boundary. There is no boundary for this. There is no limitation for this. Okay? It is a very powerful method which is going to wait as long as, even though if you pass infinite numbers, it says, I am ready to accept the infinite numbers. Are you ready to have the memory? Are you ready to deal with the memory? So there is no such thing in the world. Infinity is always the topic of debate always, isn't it? Yeah, there is no end for the infinity. There is no end for the infinity. Obviously, the memory is going to get affected. You need to have the infinite memory. Even though if you have the infinite memory, what is the problem again? Even the time is the problem. As long as you need to have the infinite time, there is no end for this. Since there is no end for this, unbounded. Okay, you should be very careful when you are dealing with the infinite string, especially when you are using sorted method. Right? So on contrast, the limit method is what? Bounded. Limit method is completely bounded. For example, see, if I introduce the limit method, the problem is solved. If I introduce the limit method, right? If I say that the limit method is 5, okay, and I want to change the log, because anyhow the numbers are going to be the sequential for 1 2 3 4 5. There is no point to use the sorted method, but I want to print the numbers in the descending order. What I want to use inside this, I want to use a comparator. My comparator will accept two values, a dot compare to. Okay, I want to print the numbers in the descending order, so I am using the minus sign. Okay, 5. Okay, now see, limit method is printing the numbers in the 5 4 3. What is happening behind the scenes? Now we'll understand why the limit method is bounded. Both are stateful, but limit method is bounded, sorted method is unbounded. Let us understand that. Now you see, guys, the numbers. This numbers is nothing but a stream. It's not a data source. It is a stream. Okay, it is going to produce stream of infinite numbers. So it starts from 1 2 3 4 5 6 7 and keeps producing numbers, isn't it? Infinite numbers, right? So limit method is the stateful method. It accepts the first 5 numbers. Okay, let me accept. Limit says let me accept the first 5 numbers, because the argument is 5 here. If you are passing 7, it is going to accept first 7. It will wait until 5 numbers, right? 4 5. Yeah, you need to understand something. Okay, the argument that is accepted by the limit method is going to be long value. It is always finite. It is going to deal with the finite. So there is a boundary here. You can draft a boundary here. You can create a space and time here. Okay, that's why they call it was the limit method is the stateful method and bounded. Stateful, it remembers the state as well as it is bounded by the space, because it is dealing with it is always going to deal with the finite numbers, right? Now, so limit method as first 5 numbers. Sorted method, okay, this sorted method is going to perform the operation in the descending order. Will accept 1, arrange the according to 2 descending order, and 2 will be accepted, and 3 will be accepted, followed by 4 will be accepted, and then 5 will be accepted, right? So they are saying, so this is also stateful. Okay, this is stateful because it remembers the state, but it is unbounded because you are now dealing with a finite value. No matter what, you're dealing with a finite value. That's why you are able, the sorted method is able to perform the actual sorting. But when you're dealing with infinite values, it cannot do it forever. Okay? Right. Now after doing all this, as soon as the limit method is satisfying, the limit method satisfies this condition, short circuiting is going to happen. Done. The loop is infinite no matter what. Okay, so that's why limit method is a stateful, bounded, and performs short circuiting operation. Short circuiting operation. Are able to follow? So you just want to understand the purpose of stateful, the purpose of stateless. Okay, just by looking at the each and every, when you are working with each and every method, you get those things here. Stateful intermediate operation. Able to understand the limit. See, short circuiting stateful intermediate operation. It is not introducing bounded or unbounded. Okay, right? So there is another stream called, for example, stream of integer, or I can say, okay, stream of integer numbers stream dot generate method is there. Okay, generate method is going to accept a supplier. You know what is a supplier? If you don't know, please revise my previous videos on supplier interface. Okay. It is not going to accept any value. For example, if you want to generate a 6-digit OTP, right? So supplier, this is the typical lambda expression. It is not going to accept anything, but the return type is what? I want to generate the random number. I want to generate an OTP. I'm using random class, right? And this is going to return a number in the decimal form from 0 to 0.9999. Okay, I want to multiply the generated number to 10. I want to typecast it to what? Integer. Okay, this is a floating. It is going to return me the floating point value. I want to typecast it to integer. Right? So let me remove this. Okay, so this is going to generate some random numbers. Again, this is going to generate the infinite random numbers. Okay, for example, if I just run this, if I just utilize this numbers variable dot, and if I convert it to what, for example, if I just directly use for each, right, and system.out.println, right, okay, sorry guys, I think my screen automatically got stopped sharing. Now you're able to see now, everyone. Am I audible now? Yes, no? Are you able to see my screen? Jyoti, Shashwant, Ratna. Okay then, okay then. So just Ratna reminded me, called me. Okay. So now you see, if I run this code, the random numbers is going to generated infinite number of times. Okay, let me stop this. The random number is going to generate infinite number, because the generate method is also going to generate the infinite values, and it is going to accept the supplier as an argument. Supplier. So you just check my previous videos, you understand what is supplier. Okay, now I want to I want to terminate this. I want to short circuit this. I do not want to depend upon the infinite number of values. I want to short circuit this. Some banks, they want to use the limit. They want to give you the 6-digit OTP. Some kind of non-enterprising applications, they want to give you the 4-digit OTP. Okay, so if I pass four random numbers is going to get generated. Okay, let me run this. It's kind of OTP, 4 random. If I run this once again, 4 random numbers is going to get generated. Once again, 4 random numbers is going to be generated. And again, like this, if I pass something like 6-digit OTP is going to get generated. Okay, and again, if I rerun this once again, and if I again rerun this once again, you will be able to see 6 OTP number. Again, I am using the limit method here. Okay, this limit method is a short circuiting method, stateful method. right? Here the purpose of generate method is to generate random numbers as long as it takes infinite number of times. Infinite random numbers is going to get generated. Infinite random numbers. Okay, and which is making this infinite to finite? Limit method. Don't you think so? Limit method is cut shorting this. Limit method is limiting the infinite operation. Limit method is what? Limiting the infinite. But the problem, there is another problem with the skip method. You know what is skip method, right? Skip method will also accept something. If you pass skip, right, it is going to skip first 6 digits. First, I mean, if you pass something, the first 6 numbers is going to get skipped, but the remaining numbers are going to get displayed in the console. Okay, so again, it is going to be an infinite thing. Going to the result is going to be an infinite thing. It keeps on printing the remaining values because the numbers itself is a stream that is an infinite, right? So if you over the skip method is stateful intermediate operation, they are saying. It remembers the state, but the problem is, okay, as soon as the state is remembered, okay, it is going to skip the first 6 elements. From the 7th, 8th element, it is going to give it to the for each method. 7, 8, 9, 10, 11, 12, okay. It keeps on giving it to the what for each method. Are able to get it? Right. So it's your duty, so we there is another method. Okay, let me introduce this stream of what we call it as, for example, empty stream. Empty. To generate an empty stream, you can't do, you are not going to do nothing with the empty stream. There is a method called empty method. Okay, so this empty method is going to give you the empty stream. So empty stream, the data type of empty stream will be like, when you are dealing with for example, you have stream of numbers, stream of integer, and you have something like set of numbers like stream dot of. Okay, the numbers are like 1, 3, 5, 7, 9. Okay, just do an observation. All the numbers are odd numbers here, right? So you are using the filter method, numbers dot filter. The purpose of the method, filter method, is it is going to accept a predicate, and you want to filter the even numbers. So the problem here is the numbers that is already there inside the stream, all the elements are of odd type, odd numbers type, right? System dot out dot println. If you run this code, the output is going to be empty. Why the output is going to be empty? The output is empty because the filter method is going to return the empty string. That's why the output is empty. Copying is not happening properly. That's 1 minute. Stop this because this is giving me the infinite loop. Okay. I need to stop this. So this is giving me the infinite stream that is getting called over and over again. It is not returning any output because output is going to be empty. Why output is going to be empty? Okay, this is the code. You have stream of numbers 1, 3, 5, 7, 9. Okay, the num is a variable. It will pass 1, 3, 5, 7, 9. But this filter method will not return anything. Okay, it consumes 1, it consumes 3, it consumes 5, it consumes 7, it consumes 9. Everything is an odd number. Every number is going to get destroyed. Right, 1 will be destroyed, 3 will be destroyed because it is not satisfying the predicate condition. So obviously it needs to get destroyed. Right, so now this filter method is going to get return an empty stream. Okay, the stream is going to be what? The empty type. Okay, now your this empty stream is operated by the for each element, which is going to accept the empty stream, but nothing is going to get displayed in the console. Okay, the return type of filter method, this time in this situation it is going to be the empty. It's going to return the empty stream of integers. Empty stream of for integers. So nothing is there to be displayed. Okay, just understand that there is a method called empty method. Since this kind of situations, the intermediate operation, sometimes they may return the empty value. That empty value will be taken care by the empty method, right? So let us understand what we have discussed so far today. So this is the if you get logged out of the meeting room, just try to rejoin. Just kind of hint. Okay, what are the things that we have discussed? So there is an operation. Okay, and you have what? You have the type. Okay, so you have the filter operation. Okay, filter operation is what type? It is what? Intermediate type. And it is what? Stateless, right? And you have map. Okay, map is also an intermediate type. It is also stateless. When I say stateless, no memory, it will not remember anything. Map method, right? And you have skip method. Skip method is what? Skip method is also an intermediate operation, but it is stateful. And it is bounded. Bounded means there is a certain boundary for this. It is bounded. So you have the limit method. Okay, limit method is also an intermediate operation, right? Limit method is also an intermediate operation. It is also stateful and the bounded. Okay, and you have a kind of method like flat map method. Flat map method is an intermediate and the stateless operation method, right? And you have like the sorted method. Sorted method is also an intermediate operation, stateful but unbounded. Stateful but unbounded. Okay, if you are passing an infinite stream, then it is the sorted method is not an helpful. Okay, like this, you have what? You have like any match method is there. Any match. Okay, it is a terminal operation. None match is a terminal operation. Right, you have for each what? Terminal operation. These are the methods that we have already discussed. What else we have? You have reduce. Reduce is a terminal operation method and it is stateful. It remembers. Okay, because you is going to reduce the sequence of numbers to a single number. Right? Stateful and it is again bounded. Right? And you have the count method. Is what? The terminal operation. Okay, so that's all about, guys. That's all about today's class. Just try to do it by yourself. Take each and every method and take a pen and paper and try to find it out whether it is a stateful or stateless, right? So you will get some complete picture. The idea is you should not be confused or you should not be kind of fainted when you get a questions like what is stateful and what is stateless operations. Right now now you got a clear idea about the stateful and stateless operations. So this is all about the today's class, and tomorrow we will continue discussing about the collector method and collectors interface, and grouping by method. So there are so many things needs to be discussed in the stream APIs. After completing that, you will get complete understanding about Java 8 features. You can crack any kind of Java interviews. Okay, so that's all.